Hello, and welcome to this lesson on the mole and measuring amounts of substances. In today's lesson, we will understand and define the mole. You have so far been familiarized with the concept of relative formula mass. Building on this, we will relate the mole to relative formula mass, which gives us a powerful tool for quantifying and comparing amounts of different substances in a standardized way. This allows us to perform calculations and make predictions about chemical reactions with greater precision. Let's dive into understanding what a mole is. When we talk about moles in chemistry, we don't mean the animal. Chemical amounts are commonly measured in moles, which is a unit used to express the quantity of a substance. When chemists talk about a mole, they're referring to a specific number of particles such as atoms, molecules, or ions. Imagine a mole as a counting unit, similar to how we use the term dozen to count 12 items. However, instead of 12, a mole counts approximately 6.022 times 10 to the power of 23 items. This might seem huge, but you need to remember that atoms are extremely tiny. This number, 6.022 times 10 to the power of 23, is called Avogadro's number. We will explore this important constant more in the next lesson. The symbol for a mole is mole. An important concept related to the mole is the mass of 1 mole of a substance. The mass of 1 mole of a substance in grams is numerically equal to its relative formula mass, mR. For example, the relative formula mass of H2O is 18. This means that a mole of H2O molecules weighs 18 grams. To link the mole to the mass of a substance, we use the equation m equals n times mR, where m is the mass of the substance in grams, n is the number of moles, and mR is the relative formula mass. This relationship simplifies conversions between the amount of substance in moles and its mass in grams. If you have 36 grams of water, you can find the number of moles of water you have by rearranging the equation to n equals m divided by mR. Plugging in the values then gives n is equal to 36 divided by 18, which equals 2 moles. This means you have 2 moles of water, or 2 times 6.02 times 10 to the power of 23 molecules of water. By mastering the mole concept and its relation to relative formula mass, you gain a critical tool for quantifying substances and navigating chemical equations and reactions with greater precision and comprehension. Let's dive into some GCSE level questions to apply our understanding of the mole concept and its relation to relative formula mass. Here is our first question on calculating moles from mass. How many moles are in 44 grams of carbon dioxide? Pause here to have a go yourself. Now, let's go through the answer. First, calculate the relative formula mass of CO2. Carbon has an atomic mass of 12. Oxygen has an atomic mass of 16, and there are 2 oxygen atoms. So, the relative formula mass of CO2 is equal to 12, plus 2 times 16, which equals 44. Now use the equation n equals m divided by mR to find the number of moles. Here, m is equal to 44 grams, and the mR is 44. Therefore, n equals 44 divided by 44, which is equal to 1 mole. This means you have 1 mole of carbon dioxide. Now onto our second example on finding mass from moles. What is the mass of 0.5 moles of sodium chloride, NaCl? Pause here to have a go yourself. First, calculate the relative formula mass of NaCl. Sodium has an atomic mass of 23. Chlorine has an atomic mass of 35.5. So the mR of NaCl equals 23 plus 3, 5.5, which is equal to 58.5. Now use the equation m equals n times mR to find the mass. Here, n is 0.5 moles and mR is 58.5. Hence, m equals 0.5 times 58.5, which is equal to 29.25 grams. This means 0.5 moles of sodium chloride weigh 29.25 grams. Through these examples, you can see how to calculate moles from mass and vice versa. This practice will solidify your understanding of the mole concept and its application in solving chemistry problems. In today's lesson, we delved into the concept of the mole as a fundamental way of measuring the amount of substance in chemistry. We began by understanding that a mole is a specific quantity, defined as 6.02 times 10 to the power of 23 particles, which can be atoms, molecules, or ions. This number is known as Avogadro's constant. We then discussed the significance of the mole in relation to relative formula mass, and understood how to convert between the mass of a substance and the number of moles. To reinforce these concepts, we worked through a variety of examples and practice problems. These included calculating the number of moles in a given mass of a substance and determining the mass required to have a specific number of moles. By understanding the mole and its connection to relative formula mass, we have gained a powerful tool for quantifying substances in chemical reactions. This knowledge is crucial for accurately performing calculations in stoichiometry, which we will explore further in future lessons.